A very good morning to the lecturer. This video is intended for BMM 3531 Engineering Thermodynamics Lab 1, titled Heat Pump. We are from Group 8 and I am Krishna Muniandy, MA18219. My team members are David Fritzen Ana Akiat, MA19154, and Muhammad Izzuddin bin Jamal Abdul Nasir, MA19209. Introduction. A heat pump is a mechanism that uses heat from a waste or surrounding heat to source to produce valuable heat. The concept of heat pump is that its medium releases the heat at a higher temperature after a chemical or physical transformation. Heat pump technology is becoming more prevalent in various industries. Its advantages include lower energy consumption, better working conditions, and faster installations. Next, a basic working principle of this heat pump is the flow passes through a cycle of four distinct processes. The first, which is evaporation, where evaporation at lower pressure and temperature absorbing heat from cold space. Next, compression, where the flow is being compressed, where the compression occurs to make the flow become high pressure by work input. Next, cooling and condensation at high pressure and high temperature, delivering heat to the hot space. Next, expansion by throttling through a valve from high pressure to the low pressure. There are some problem statements that have been fixed for this experiment. The first is the problem to be addressed through this project is to observe how the heat pump works. From this experiment, we can also investigate how thermodynamics affect the working principles of heat pump. To understand this, we need to observe the coefficient of performance (COP) of the heat pump. We also need to calculate and find the theoretical value of a COP heat pump in a steady state situation and compare the results with the real life values obtained through experiments. We should also need to understand the discrepancies that occur because of the difference between the experimental value and theoretical value. Next, the main objectives for this experiment is using calculative methods to find the coefficient of performance (COP) of the heat pumps. Next, we also need to compare the calculation performance of heat pumps between the calculative results and also the experimental results, and explain the discrepancies, which are the errors and differences. Next, the scope of this experiment is the analysis on evaporator, condenser, expansion valve, and compressor. Next, to also discuss and produce the performance of the heat pump.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Jamal Abdul Nasir. My metric number is MA19209, and I will present about the literature review. Firstly, the introduction of the heat pump. It is a device used to transfer thermal energy in a confined space and outside. This device can be used to heat or cool a building. When the heating process takes place, the energy is moved from outside into the building. Meanwhile, for cooling, it is vice versa from the heating process. This device is very efficient and rising share of fossil-free electricity. It is a crucial part in energy transition and climate change mitigation. This device can transfer 3 to 6 kWh of thermal energy with only 1 kWh of power. It's very efficient. And this heat pump can be seen nearby us with the application of air conditioner and refrigerator for the cooling process. This is the picture of a heating process cycle. Firstly, in the evaporator, the liquid refrigerant absorbs heat from the outside air and turns into a gas. Then the refrigerant is forced via a compressor with increase the gas pressure and thus its temperature. And then the hot gas through the condenser coil within the heated space and because is it hotter than in the room, it transfer heat to the condenser back to the liquid. And finally, the liquid pass through a valve that lower a pressure and allowing it to cool down and resume the cycle. And next is for the cooling process cycle. In the evaporator, the cold refrigerant absorbs heat from the hotter chamber, causing the room to cool. The temperature is then raised by passing it through a compressor. It travels via condenser coil where it is transferred to the outside. To repeat the cycle, it expands to its lower pressure and cool down to below the room temperature. Next is the schematic diagram for the heat pump. There are basically four parts in the pump, which is expansion valve. It allows the liquid refrigerant to expand or change state from a liquid to a vapor. And then condenser used to cooling device for in-process fluid are made of this material. Condenser are used in refrigeration system and are utilized in refrigeration. Next is compressor. It's a device that reduces the volume of a substance, usually gas, in order to increase its pressure. And lastly, last part is evaporator. Device is used to employ in the conversion of a chemical substance liquid form, such as water, to its gaseous form into a vapor. And next is the type of heat pump. There are basically three types, which is use water source as its thermal energy transfer. It is cheap and also easy to install. It is wide and work well in any temperature. It is widely used and easy to use, easy to operate. Next is water source. Instead of using water, instead of using air, it's using water as a source of thermal energy transfer. This is rarely used because they are required access to a well, lake, and other water supply. And lastly, the ground source, which is geothermal heat pump used to transfer the thermal energy. It is same as air source, but it is very expensive but more efficient. Because it is expensive because excavation and ground piping installation is needed. And lastly, the refrigerant we used in this experiment, which is A-134A, also known as tetrafluoride fluorine CF3CH2F. HFC is included in HFC refrigerant family. It also replace CFC and HCFC refrigerant that can be harmful to the environment. This refrigerant also non-toxic, non-flammable, and non-corrosive. It's very safe and to use widely in use and can be used daily. This is the equation that we use throughout the experiment, which is cooling water flow rate divided by 100 and times by 5.0. The next is refrigerant flow rate. Refrigerant flow rate divided by 100 and times by 1.24. The next is coefficient of performance equation. Generally, it is Cp. The Cp equal to Q divided by W. And it also can be also known as temperature high is hot divided by temperature hot minus temperature cold. That's all from me.
Hi, my name is David Fritson Anakiat, MA 19154. So now I will proceed to present about the chapter 3 methodology and also chapter 4 results and also discussions. So in the methodology, we have the tools and equipment. For the machine we use for the experiment is the heat pump. So this is the heat pump, mechanical heat pump unit brain, Soltec model HE165A. So in the heat pump, there is evaporator, compressor, expansion valves, condenser, temperature sensors, pressure sensors, refrigerant flow meter, cooling water flow meter, and also control board. So the medium for the heat exchange is refrigerant R134A. So refrigerant is compressed and cycled through system by compressor, and the heated highly pressure vapor is then cooled by the condenser until it condenses into a high pressure and moderate temperature liquid. So the condensed refrigerant is subsequently transferred through a metering mechanism which lowers the pressure, which is known as expansion valve. The low pressure liquid refrigerant next passes through an evaporator, a heat exchanger, where the fluid absorbs heat. The refrigerant then transferred back to the compressor. So here is the procedures. First of all, switch on the power supply, and the flow rate of the cooling water is determined and controlled. The compressor and water pump is switched on. And number 4, the system is allowed to be in a steady state. Number 5, experimental data consisting of refrigerant flow rate, cooling water flow rate, temperature 1 until temperature 6, pressure 1 and pressure 2 are collected from the reading of the screens on the heat pump. So the experiment is repeated with the different cooling water flow rate. So the calculations, there are 3 calculations or data that we need to calculate for this experiment, which are the enthalpy H and entropy S, which we can refer table A11 and do some interpolations. So for the coefficient of performance, there are 2 coefficient of performance, which is the COP for the refrigerant and COP for the heat pump. So here you can see the formula for the COP. And for results and discussion, so here you can see the raw data for this experiment from experiment 1 and experiment 2 with different flow rate of cooling water. So here are the overall calculations for the entropy, which is shown here is the interpolation of the entropy with the given temperature, and also the same approach for the enthalpy. And next is the coefficient of performance, and here you can see 4 experiments with different COP. The next is the TS diagram. As you can see here, the TS diagram shows that almost 4 of the experiments have the same orientation. And from point 1, point 2, there is an increase in temperature, but in almost slightly different entropy. So here is the pH diagram. You can see the pH diagram, which is almost like a trapezium, which indicates that this process, this is pressure and enthalpy that we have obtained from the calculations. So this is the COP diagram. So this COP increase if the water flow rate increase. So that's all from me. Thank you.
For the discussion part, the first question is, explain the factors that affect the COP. The COP is affected by temperature difference between inside and outside. The COP, the ratio of cooling load of the culture room to the electricity consumption of air conditioners or electric energy used by the air conditioner, is influenced by several factors. One of the factors is the size of expansion valve. Result of COP shows that the COPs of the heat pump system is increasing from fully closed valve to 20% open to 60% and fully open valve. Fully open shows the highest volume flow rate. When the valve is fully open or more open, more water will flow through the pipe. So the result occurs as a good heat exchanger in the condenser. This shows that a higher flow rate situation indicated the highest coefficient of performance of the heat pump. Next question, explain the reason behind the discrepancies between the experimental data and theoretical data. A refrigerator condenser having varied shape bands, sharp bands, and wherever the bore of the pipe is tiny enough to cause high rate flows can cause excessive refrigerant pressure to drop from viscous friction. Important error may arise in calculation if the condensation method is assumed to occur at constant pressure. Such limitations should be thought about within the style of instructional instrumentation to provide pregnant results. The refrigerant going away the evaporator can in most operative conditions be below close temperature, leading to a high heat gain from the environment to exceed superheat. The suction line is sufficiently insulated to permit the belief that this doesn't occur. Viscous frictions within the suction line manufactures a pressure drop, excluding the very fact that the refrigerant is within the vapor state, giving low resistance losses. The suction line is extremely short, long, and the pressure drop is quite tiny. Next, for question 3, discuss ways to decrease the discrepancies between the experimental and theoretical data. The accuracy can be improved through scientific methods if every single measurement is created correctly and conjointly through the selection of instrumentation. Implementing a way that reduces systemic error across the system can improve accuracy as well. Next, the continuous single measurement for each recorded data will improve the reliability of single measurement and increase the quantity of repetition of every measurement and use the averaging word.
The conclusion. Based on the experiment, we already learned how the heat pump works. We also learned the working principle of the heat pump method to thermodynamics. We have evaluated the coefficient of performance of the heat pump. We have calculated the COP of the heat pump, condenser, and evaporator. We also plot the TS diagram and pH diagram from the theoretical formula and the result we gained from the experiment. From the discussion, we can conclude that the graph for experimental result is almost exactly with the theoretical calculation. We have learned that the experiment conducted successfully and the data obtained is correlation. All the experiment debate can be obtained from the discussion with expected answer. Thank you.